The difference between a B and an A star in biology? Well, it often comes down to mastering one highly specific, incredibly analytical area. We're talking about topic 14.1, urine formation, specifically selective reabsorption in the proximal convoluted tubule. 0. That is exactly how many marks you're going to get for a perfectly correct conclusion if you don't show you're working. It's a cold hard truth, but this massive recurring mistake constantly costs candidates entire letter grades.
Section 1, the costly exam mistake. Okay, let's dive right into this. In this explainer, we're looking at exactly what Cambridge examiners are searching for when they grade your papers. We aren't just memorizing textbook facts here, we're literally decoding the mark scheme itself. Now take a second, I want you to mentally predict why standard revision completely fails for this specific topic. Why do typically A-grade students suddenly crash when evaluating evidence and drawing conclusions about the kidney? Really think about it before I reveal the senior examiner's top warnings.
All right, here are the top 3 mistakes directly extracted from the Cambridge Principal Examiner reports that absolutely destroy grade boundaries. Number 1, confusing cause and effect. Number 2, forgetting units and crucial scientific terminology. And number 3, writing generic answers that just aren't specific to the actual context of the question.
Which brings us to Section 2, PCT Core Biological Principles. To avoid those traps, you've got to understand that top-performing candidates exhibit a deeply connected conceptual understanding. It's not about reciting facts, it's about a grasp of biological principles that transfers smoothly to completely unfamiliar exam contexts. Notice how this assessment is framed. Selective reabsorption in the proximal convoluted tubule is a critical process requiring systematic analysis. Questions here target distinct cognitive domains. They test your knowledge, sure, but also your ability to handle information and your experimental skills. Basically, analytical depth is prioritized over superficial breadth. Let's fix that number 1 examiner warning right now. We need to break down cause versus effect in the PCT. For instance, the active transport of sodium ions out of the PCT cells by the sodium-potassium pump, that's the cause. The effect is the lowering of the sodium ion concentration inside the cell, which then creates a concentration gradient for sodium to diffuse back in from the lumen, bringing glucose right along with it. If you mix up which action drives the next reaction, your biological logic just completely collapses. Now, in a moment, I'll show you the examiner clue that changes the answer completely. But first, you really need the framework that makes that clue obvious, because without it, even the best students miss the signals hidden right there in the question. Section 3, the method mark strategy. This is a foundational, elite tactic where marks are awarded for the scientific and mathematical process itself, not just the final destination. The crucial point is captured beautifully right here. Even if your final answer is wrong, method marks can save you. Show you're working. A minor calculation slip under time pressure shouldn't ruin your score. Systematic processing is the ultimate safety net for Cambridge biology candidates. To actually secure those marks, you need a strict procedural framework. Step 1, deconstruct the question. Step 2, extract relevant data from the stimulus materials. Step 3, select your analytical framework. Step 4, execute with clear notation. And Step 5, present your final answer with the absolute correct terminology. Section 4, fixing a flawed answer. Let's pull this into the real world. We're going to apply this framework by comparing a typical flawed student answer with a top band, A-star answer, to see exactly how these steps look in practice. But before we do, act like a senior examiner for a second. Pause and predict. When you review your own work, can you spot the error before the examiner does? You should constantly be scanning for missing evidence, missing data points, and gaps in your scientific reasoning. Okay, here we go. A flawed student answer might state a technically correct biological fact about glucose moving into the blood, but it completely misses the underlying working and data references. Compare that to an improved top band answer. You'll notice clear notation and correct terminology, using terms like co-transport and facilitated diffusion accurately. It explicitly links the biological concept to the specific evidence provided. That step-by-step framework is what secures those maximum method marks. Section 5, top examiner warnings revealed. Securing method marks is fantastic, but evaluative thinking, that is the final hurdle to crossing that top grade boundary. Top-scoring candidates demonstrate evaluative thinking by questioning assumptions and justifying decisions with evidence. Evaluating evidence quality regarding the proximal convoluted tubule means you have to actively identify limitations in experimental setups, spot assumptions being made about filtration rates, and suggest alternative interpretations of the data.
Let's see how this builds into your ultimate problem-solving flow for complex data analysis. 1. Identify the given information. 2. Break it into logical steps. 3. Solve systematically. 4. Check for reasonableness, like, does this concentration actually make biological sense? And 5. Justify your recommendations. This flow ensures you leave absolutely no marks on the table.
Section 6, the final diagnostic challenge. We've covered the conceptual framework, the method marks, and the evaluation. Now it's time to solidify your learning on PCT selective reabsorption. Let's quickly lock in our 3 key takeaways from this explainer. 1. Process over final answer. Always show you're working. 2. Verify your units and apply them strictly to the context of the question. And 3. Create your own key term mnemonic. Take the first letters of crucial terms like microvilli, mitochondria, cotransport, and active transport, and create a quick memory hack to lock the biology right into your brain.
Now for the diagnostic cliffhanger. What if you have the perfect biology memorized, your mnemonic works beautifully, your working is totally shown, but you still drop to the wrong mark band? Why? Because of one hidden cause. Understanding PCT biology is only half the battle if you misunderstand the examiner's specific command words. If you simply describe when you are meant to explain, well, all that brilliant biology isn't going to save your grade. This unresolved problem is exactly what you must tackle next. You absolutely need to know the command words that decide the mark band. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations, and head straight over to our next explainer to master those command words and secure your top grade.